Hi everyone, welcome back to Code Era. So in this video, we'll be discussing the problem C from the latest CodeForces round 752, division 2. And let's read the problem statement. So it says that you have been given integers sequence A1, A2 up till AN. That is, you have been given n integers. And you can perform the operation until the sequence becomes empty. Okay. Select an index I such that the index is valid, such that the index is from not valid, but such that the index, the I that you are selecting, it should be between 1 to A, and AI is not divisible by I plus 1. Okay, erase this element from the sequence. If the element AI is not divisible by I plus 1 for a particular I, if that I is not divisible by I plus 1, then you simply erase it, okay, from the sequence. This is what has been said. And here mod a is the length of the sequence at the particular moment. So this is what I was telling, that the I should be valid. By validity of I, we basically mean that let's suppose that we have removed one element, and let's suppose the size was initially n. So when you remove one element, so now the new size of the sequence will be n minus 1. So this is what you need to keep a track of. That is how your I should be valid. So you should be choosing the elements that are available only, and the indexes that are currently available, not the deleted ones. So for example, if you have 3, 5, 4 and 5, so you can see that for the element I is equal to 2, that is the element which is having 5. So in this you can see that if for this this is 5, but I is 2 for this. But if when you have to check the divisibility with I plus 1, okay, so if you check the divisibility for 5 with I plus 1, then you will observe that you will get simply 3. I plus 1 will be 3. So you can see that it is not divisible. 5 is not divisible by I plus 1, that is 3. So when you will do the mod, so you will get some remainder. So that is why you will remove this element. Once you remove this 5 at the index I is equal to 2, so the new array will look like 3, 4 and 5, right? So this is what one deletion means. And you have to determine whether it is possible to erase the whole subsequence using this operation or not, right? So let's move to the whiteboard, and if it is possible to make the complete sequence empty, that is the initial array or the integer sequence that has been given to you, if you can make it as empty, then you will simply print yes if you can remove all the elements in such a way. If you cannot do so, then you will print no. Okay, so this was the problem statement. Now let's try and see some test cases so that we can understand the problem better, right? So let's say initially I've been given n is equal to 3. If I was given n is equal to 3 and my array looked like 1, then 2 and then 3, okay, so for this array you can observe one thing, that how can I delete this array, right? So if you, one more thing that before moving on I want to tell you is that the indexes will be starting from 1. okay, I will start from 1 for here. Okay, so this is something that you just need to keep a track of, so that you just don't miss it, right? So let's say you have this sequence, right? So how can we delete this? So for this index, it the value of I plus 1 will be 2, right? If the value of I plus 1 is 2, so that, what does that mean? That simply indicates that I can remove this element. But wait a minute, should we do it like that? No, we should not do it like that, because what will happen is, let's first of all do something that I want to discuss, like how first of all we should approach. So for this, what will be the value of I plus 1? It will be nothing but 4. These are the values of the elements, and I'll keep the values of I plus 1 here. So what is the value of I plus 1 for each index? So for this value, for this element, the value of I plus 1 is 2. For this, the value of I plus 1 is 3. If you see, if we first of all, if you will pick this index, right, if you pick I is equal to 3, then you will see that 3 mod 4 is not equal to 0, right? So some remainder is remaining, so that is why you can remove this element, right? So let's say you remove this element first of all, you can remove this 3, then you can see that the array doesn't change, so the indexes will remain the same, because there is no element from the beginning or in the middle that has been removed. If the last element has got removed, that is array the element 3 at the third index, so it will not impact other indexes, right? So indexes will remain the same. So now you can see that 2 2 mod 3, what will it give me? 2 mod 3 will give me a 0, right? So since 2 mod 3 is 2 mod 3 will not give me a 0, so that means that I can also remove this element. So similarly, I will remove this element from the array. Once I remove this element as well, so you can see that my index is not changing, because if I am changing something in the prefix, so suffix, suffix, so the prefix will not change. So similarly for this element, my index will not change for this element as well. So you can see that 1 mod 2, what does that give me? 1 mod 2 is not equal to 0, so that means some remainder is there. So the reason that some remainder is still there, so that simply indicates that what I need to notice is that I can also remove this element, right? So in this way you can see that all the elements are removed. So since all the elements are removed, so you can say that you can print a yes. Okay, this is what you can do. But now let's check for another test case, right? Let's check for another case. So let's say that I give you a test case and the value of that test case is 1. What I'm saying is, let's say n is equal to 1 and the element is 2. Okay, if the element is 2, then for this element the I will be 1 for this element, because this is the first element, but the value of I plus 1 for this element will be 2, right? So you can see that 2 mod 2 will give me a 0, right? So it gives me a remainder equal to 0, which simply indicates that this element cannot be removed. And does the can I have any other index for this 2? No, I cannot have. So this is why you will print a no for this, because you cannot change it, because you cannot delete this sequence. This sequence, only one element is remain in this sequence, but you cannot empty this, because the I plus 1 is 2 and it will when you will mod, so it will not give you any remainder. The remainder will be 0. So that is why you cannot remove it. So you cannot empty this particular subsequence, right? Similarly, if you check for this 7 and 7, the elements, let's see this third test case. So if I give you n is equal to 2 and I give the element 7 and 7, so in this case what will happen is, for this the index will be what? 2. I plus 1 will be 2. For this the I plus 1 value will be 3, right? So 7 mod 2 will not have any impact, so I can remove this. After this, let's suppose that I have removed this, so I can this element's index will now change. This will be I is equal to 1 for the new sequence, so I plus 1 will be 2. So you check and you can say yes, I can remove this as well. So you will print yes, that you can empty this particular subsequence, right? So this is why yes, no and yes, this is how you will be printing for these test cases. Now let me show you another case, like when can we encounter a situation such that it is never possible for us to remove the elements, right? So let's say I give you an element, let's say I give you 8, right? And then let's say we have another element and that element is nothing but 9. Okay, that element, let's say, is 9, and the next element that I want to talk about, let's say I give you 120. Okay, so if you will see, so can I make this array as empty? Let's check. So for this the I plus 1 will be 2 initially the I plus 1 will be 3. For this the I plus 1 will be 4, right? So for this array you can see that number of elements are 3, and you can see, can I remove any element, any possible element? No, I cannot. The reason is because for this element 120, you can see that it is not divisible, right? It is not divisible, it is divisible by 4, so it does not give me any remainder in the end. So that is why I cannot remove it. Similarly, I cannot remove this element as well. Similarly, I cannot remove this element. Now let me change the test case a little bit. Let's say instead of this 8, I was having something like 10. Okay, so what can I say? If I was having 10, then I can simply remove this element. Once I remove this element, then instead of this 4, this will be the second, I will be 2 for this, so I plus 1 will be 3 for this element. So you can now see that that this element will still cannot be removed, because 120 mod 3 is equal to 0. So that means that I cannot remove this element, right? Even if this element, let's say it was 7, let's say this element was 7, then what would have happened? You would have removed this element and the index for this element would have been nothing but I is equal to 1, so I plus 1 will be 2 for this, right? The value of I plus 1 would have been 2. So in this case, what would have happened with you is that even now you cannot remove it, right? So when is the situation when you cannot remove an element? So you cannot remove an element when for a particular element, let's say a of I, when a particular element that has been given to you, or when, let's say let's not take a of I, let's take x, because we are obviously changing our indexing, so that is why a of I will not be much comfortable like in understanding terms. Let's say I have an element x, and for that element, if that element is divisible by all the numbers, if a particular element x is divisible by all the indexes from I plus 1 till 2, so in the decreasing manner, if it is divisible from all the indexes from I plus 1 to 2, then that means that I cannot remove up this element, right? And if there exists any one particular element such that I cannot remove it, right? So this will mean that I'll have to print no, because if even if single element is left in the array such that I cannot remove it, so in the end I'll print no. If I can remove all elements, if there is some element x and I find one such number which is not a factor from 2 to I plus 1, which is not a factor of x, then that means it will give me x mod that particular number y. Let's say we pick a random number from here y. So if we do this, so x mod y will give me some remainder, okay, and that will not be 0, okay. This is what we are trying to do. So now someone will say, how can we do this? So now this question, this is where the beauty of this questions comes. So what happens is, let's suppose that we are taking all the elements, right? So let's suppose that we are taking all the elements as an input. I'll not declare an array, simply I'll input my all the elements in terms of x only, because since we can only check, we have to print yes or no only, so that is the reason why I'm not doing this. Now next up, what I can do is, let's say I also take a flag, and initially my flag will be what? Let's assume that initially I mark my flag as true. The reason why I'm marking my flag as true, because initially I'll assume that I can make let's say initially I'll assume that I can make my the sequence empty, okay. So since once I'm getting this, so what I can do is, what we can generally in a brute force manner, what you will think is what most of us had think in the problem during the contest. So my j will start from my j index can start from I plus 1, and I will check for all the elements from I plus 1 to 2, and I'll simply do a j minus minus, and I will check that if there is a particular element, if there is a particular element such that there comes a situation that the x that has been given to us, if x mod j, if my x mod j is giving me some remainder, then that will be perfectly fine, right? That will be perfectly fine, because this will be a good situation for us, right? If this gives me a remainder, then I will mark my for this particular, I will keep on a check x mod j. For this I'll also declare a bool variable bool check, and what I'll do is, what this bool check will do, initially I'll mark it as false. So whenever I get index j such that for the particular ith element, or for a particular element, for the current element of the array, if I can remove it between any index I plus 1 to j is greater equal to 2, if I can remove it, so I'll simply mark my check as true, and I can break from this, right? Because I can remove this element because it is giving me some remainder, right? And the remainder is not 0. But what happens in after the end, if I get a situation such that after the iteration is over for a particular element from I plus 1 to j is greater equal to 2, then what I'll check, if my check is false, right? If my check is false, so that will mean that I could not find any element, any particular index such that any particular index I plus 1 for a particular index I could not find any number from I plus 1 to 2 such that the remainder was coming, there was some remainder remaining and it was not 0, right? So that will simply mean that I will need to mark my flag as false, because if I cannot remove a particular element, so that means that at the end my sequence will not be empty. This is what I'll try to do. But now some people will say that the value of n is quite large, okay. Let's say the value of n is 10 to the power 5, okay, 1 into 10 to the power 5, this is the value. So someone will say that in this case the solution might look like brute force n square, but this was the trick behind the question. The question, if you will submit this solution, some people will think that this is brute force n square, but that is not the case, because what happens is, if you will see this, if you will look closely to this solution, then this loop will not run more than 22 or 23 times, okay. Why and how? So I told you that for a particular element, let's say x, it should be for it to remain, for it to not get erased for a particular element. Let's say I have a current element x, okay. For the current element x, for it to not get removed, for it to remain in the array, what I'll need to do is, the condition is that it should not be, it should be divisible from all the elements from I plus 1 to 2, right? It should be divisible for all the indexes I plus 1 to 2, right? For all these indexes. And if that is the case, that means if it is divisible, if a particular element x is divisible by all the numbers from I plus 1 to 2, so that simply means that this number will also be divisible by the LCM of all these indexes, right? This number, if this number is divisible by all these numbers, if this number x is divisible by all these numbers ranging from I plus 1 to 2, so that means that this number x modulo the LCM of all these numbers 2, 3 up till I plus 1, it will be divisible from the LCM of these numbers as well, right? So it should give us 0, right? But let's see one more thing. Let's try and see. So if you will calculate LCM, so what is LCM? LCM is the least common multiple, right? So if you will try and calculate the LCM up till 23 only, so from 2 to 23 for a particular index I is equal to 22, the indexing will go till 23, right? From 2 to 23. So this number will come out to be greater than 10 to the power 9, and the array element can be maximum 10 to the power 9, okay? So you can see that if a particular element x is divisible by all the numbers from I plus 1 to 2, so even if the index I is equal to 22, then then the LCM will come out to be 10 to the power 9. And if the element is divisible from all the numbers starting from 2 up till I plus 1, and let's suppose so that will mean that it should be divisible from the LCM of all these numbers from I2 to I plus 1. LCM of these numbers in the range 2 to I plus 1, it should be divisible from the LCM as well. But if you will check the LCM, so LCM for 2 to 23, let's suppose I is equal to 22, so for 2 to 23, the LCM will come out to be greater than 10 to the power 9. And once if you can see that if it will be greater, if the LCM that we are getting, if this LCM is greater than 10 to the power 5, so this means that it is not possible. Why? Because we have n is equal to 10 to the power 5, right? We have n is equal to 10 to the power 5. We have so many elements, and if we have so many elements, so we have a lot of indexes, right? We have indexes starting, we have the values of I plus 1 starting from 2 up till 10 to the power 5 plus 1, considering that if n is given to be 10 to the power 5, that is the worst maximum possible. So if that is the case, then this will give me a bigger LCM, right? And if this x is divisible by all these numbers, so x should also be divisible by the LCM. So if x was divisible by the LCM, then how can this be possible? Because if your array, if x can lie anything from 1, let's say from 1 to 10 to the power 5, and my LCM itself is greater than LCM is coming out to be greater than 10 to the power 9, okay? If the LCM for smaller from 2 to 23 only, if the LCM from 2 to 23, 2 from all the numbers 2, 3 up till 23 is coming out to be greater than 10 to the power 9, okay? So if the LCM is coming out to be greater than 10 to the power 9, so that means that only till 23 or 22 indexes I can see that it will not be possible, because when I'll modulo this x with the LCM of the numbers from 2 to I plus 1, let's say the value of I is 45 or something, then it will mean that for the bigger values the LCM will be so large such that you will not get some remainder you will get some remainder at the end. And if there are numbers such that you are getting remainders, so that will mean that you can remove the particular number x. Similarly, you can remove a lot of numbers. That is why I'm saying that this code that I have written, this particular inner loop will not run more than 23 times, okay? So that is why 22 or 23 you can say. So 23 into n will be the time complexity for this loop, because you are also breaking, right? And you can see that it will not be possible, because if a number is divisible by all the numbers from 2 to I plus 1, so it should also be divisible from the LCM, right? But you can see the LCM from 2 to 23, LCM of numbers from 2, 3 up till 23, LCM is coming out to be greater than 10 to the power 9, and a particular x and the value of x is at maximum 10 to the power 10 to the power 9, right? And for so this means that if x is greater than 10 to the power 9, if x is lesser than 10 to the power 9, and my LCM is coming out to be greater than 10 to the power 9, so whenever there is a situation such that I divide a smaller number, I do this modulo of a smaller number with a bigger number, so it will give me some remainder such that the remainder is not equal to 0, right? So this means that my remainder will be there. So that means that simply means that I will not be iterating n is for n times in the inner loop, right? So this is why the inner loop, the inner loop that I have placed inside the j loop will run only at maximum 23 times or lesser in practice, while for many test cases. So that is why 23 into n, order of 23 into n will be the time complexity for this problem, because if a particular number x is divisible, I'll sum up again. So if a particular number x is divisible from all the numbers from 2, 3 up till I plus 1, so that means that particular number should be divisible from the LCM of all the numbers from 2 up till I plus 1, right? And if this number is divisible from this, so it is perfect. But if you see LCM of 2 up till 23, right, 2, 3 up till 23, so this will itself be greater than 10 to the power 9, and x, let's suppose x, what is the value of x? X can be maximum 10 to the power 9, right? So if x is something closer to 10 to the power 9, and let's say I pick I is equal to 45 for example, so from 2, 3 up till 45 the LCM will be a very large value. Okay, it will be divided by a value which is greater than, okay, this value that I'll be getting will be greater than 10 to the power 9, and whenever I take LCM for a smaller value modulus a bigger value, so the remainder comes out to be the smaller number itself, right? Smaller number itself. So this means the remainder will come out to be non-zero, right? So this is why my inner loop will be running 23 times at maximum in practice, and I'll multiply n to it, right? I'll multiply n to it because I am checking for all the elements. So that is why it will be very much close to linear time complexity, and this is why this particular code that I have written, or that we had thought that was brute force, it is not a brute force, because this is the property, this is the mathematical approach, this is the mathematical beauty of this problem, that for LCM from 2 till 23, if it is greater than 10 to the power 9, so that means if the array size is large, if the number of elements in the sequence is large, if the sequence is large itself, so that means that you will always get situations such that x is not divisible by the LCM, right? Because you will get some remainder. In this way, because of this your inner loop will not be running more than 23 times. So this is how you will save the time complexity, and some people might have thought this only, and they had just submitted the brute force code and it got accepted. The reason was because this code is not naive or brute force. Obviously some people could not prove it, but this is the LCM property for this question. Okay, let me show you the code part that I had written, accepted code that I had written. So you can see this. I'll take n as an input, then I'll first of all I'll take t test cases, then I'll take n as input. I'll mark my flag as false for all the elements. I'll take x, the particular element, the current element, and I'll say that currently I haven't found any index j such that x mod j is not equal to 0, right? You can say x mod j does not equal to 0, or you can just write that in C++, but in Java you need to write not equal to 0. In this case, what will happen? My j will start from I plus 1 up till j is greater or equal to 2, right? And if I find some index j from I plus 1 till 2, such that the current value x is not giving me is giving me some remainder which is not equal to 0, so that is when I'll say that I have found a particular index I plus 1 for this particular element x, and I'll break, and I'll keep on taking the AND. So in the end, in the static I have assumed this to be true if there is some element for which the found value is false, so that will make my flag entirely false because I am taking AND operator. So in the end, if my flag is true, that means for all the elements from 1 to n, it is possible for all the n elements, it is possible to remove them, because they can be there can be indexes, there can be an index I plus 1, there can be a number I plus 1 which is remaining, which is giving me some modulus, right, which is giving me some remainder for them, which is not 0, right? So if that is the case, if flag is still true by in the end, so that will mean that all the elements can be removed from the from the sequence, deleted from the sequence. I'll simply print a yes, otherwise I'll print a no. So thank you everyone for watching this video, and in case if you have any doubt with this question, you can mention that in the comments and I'll reply back to your doubt as soon as possible. We have provided the problem link and the solution code in the description, so please check it out. Do like the video and subscribe the channel. Thanks a lot.